You make a start.
Yes, you can start.
Right.
We started the recording.
Yep.
And yeah.
Okay, well, look, thank you everybody for coming along. Like I say, hopefully you've made a good choice to come along to my presentation. I had hoped to go back to the hotel last evening and refresh my memory on what it was all about, but sadly I was distracted and spent most of the evening in Brewdog. So these things happen, you know, but we had some worthwhile discussions and that was good. So I'll bungle my way through this and hopefully we'll get there in 50 minutes and there'll be something vaguely useful for you to take away. Perhaps that will be that you never come again to one of my presentations. But anyway, as some of you probably know who are used to working with me or have worked with me in the past, one of my favorite things in the software industry is playing around with message queuing. And I also like to sort of look at what the latest trends are and see whether there's something we can do there and how we can potentially relate it to OpenVMS. And I was doing something actually a little while back, talking to a customer in Sweden as it happens. And it just triggered something with me. The customer was kind of lamenting. It was one of those things where traditional VMS system, which is very batch oriented, you know, so every time some change happens within the system, there's a record written to a sequential file. Then at the end of the day, there's a batch job that's run and some processing occurs and the results get disseminated to where they need to go. Now, what that means is that the recipients of that information aren't getting it for 8, 12, 24 hours maybe, okay? And the discussion I had with this customer was, well, could we switch this to using like event-driven architecture, where essentially when that record is written to the file for processing later on, let's not change our system, but could we transmit that event somewhere where anything that's interested in it can pick it up? So it occurred to me there's actually a way with these legacy VMS applications, not all of them, but some of them at least, where we can actually apply principles of event-driven architecture to make certain business efficiencies and to actually help you to integrate those legacy applications with new systems that, you know, the CIO decided were a good idea. So in terms of agenda, we'll just talk a little bit about what I actually mean by event-driven architecture. And to be honest with you, that is a little bit fluffy. It's like one of these trendy names. And then I'll try and convince you why you need it. Just very, very quickly, look at some common use cases, things like that. Some of the sorts of difficulties, and then we'll start getting on to the more interesting stuff of talking about relevance to legacy systems. And I feel a little bit bad using the word legacy in the context of VMS, but I couldn't think of a better word at the time, heritage system, whatever you want to call it, but old software that worked in a particular way 30 years ago, and maybe there are better ways we could do things today without having to turn that entire system on its head. And then I had another conversation with a customer. I talked to all sorts of interesting customers, and they have great ideas. And you know how when you call up a bank or the insurance company because you've got a problem or whatever, and you get the help desk, and it might be some incredibly helpful Vietnamese lady, and you can hear the chickens in the background when you're on the phone call, you know. But they're always very polite and they sort out your problem. And then at the end of the call, they will always say, now, is there anything else we can help you with today, Mr. Cameron? Go, no, it's fine. So I was on this call with a customer and it got to the end of the call and I was feeling in a particularly facetious mood. And I said, is there anything else we can help you with today, Mr. Customer? And the customer goes, well, actually, Brett. And I thought, darn, I wish I hadn't asked that question because the call lasted another half hour and I wanted a coffee because, you know, I'm in an awkward time zone in New Zealand and this customer was probably like lunchtime for them or something. So, but anyway, they got me thinking more about what we could do with this whole event-driven architecture and change data capture. Okay, we've got Tom here from JCC Consulting, so he's intimately familiar far more than me with change data capture. But it occurred to me there's actually a lot of fun we can have here, and I've had conversations with Hein van den Heuvel, and I'll probably chip in on Hein's talk later on today. And that customer conversation, just starting to think about all of these things, and I'll then kind of digress on a bit of a tangent with some trivial examples and a bit of an idea I've come up with, which I think might hopefully be somewhat useful to some of our customers, possibly even some of you in this room. If not, well, never mind. I've provided you with a little bit of entertainment. Now, so what is event-driven architecture? Well, I've described it there, and you can read the English as well as I can. In fact, probably better from the angle that you're at. But essentially, you know, there are trends in the software industry. You know, Gartner put out all these publications, you should be doing this, you should be doing that, whatever. But the idea here, if you look at this diagram, I mean, the bit on your left there is your typical monolith. You know, you've got the old application, it's got all the bits are all intertwined and tangled up together and so forth. It's very hard to change anything. It's very hard to add new bits and pieces. I mean, ultimately, if you think about it, somebody places an order, right? The order's happened. Why do I have to wait for something else down here to actually know about it? You know, I can actually get on with processing more orders. If I just throw the fact that I've got an order onto an event bus, which is essentially a message queue, the orders bit has done its work, right? It can be confident that eventually other things that are interested in that event are going to consume it and do what they need to do with it. In this way, you've got an awful lot of decoupling, right? It's easier to plug in other systems. If some other system needs to know about the messages coming from orders, you can just plug that onto the event bus. So this is classic pub sub, publish, subscribe. So if you look at it really simplistically, that's event-driven architecture. You're pulling apart all those little bits, and you're making things a lot more asynchronous, okay? Instead of synchronous request response, you've got to wait for something to come back. No, I trust the event bus. We're not going to lose any messages. Things are going to get processed in the right order, et cetera, et cetera. So in a few more words there, it's a versatile approach to building your applications, right? It can make things easier to model because you just model those basic building blocks. Now, of course, this is not a new concept, it's a new name. And the trouble is when you give something a name in the software industry, it takes on a life of its own and people think they have to have it. And then it goes through Gartner's trough of disillusionment. And what Gartner don't realize is that they were the ones that created the flipping hype curve in the first place. But it differs from things like service-oriented architecture and microservices in terms of how the data operations are handled, okay? So in an event-driven architecture, components react to events as they occur, and it tends to be somewhat asynchronous. You know, I started thinking about ASTs and things like that, if you like. And there have been some studies in recent times that a friend of mine who I think he's still the CEO of Solace Systems, so they just call themselves Solace now, but they create like message queuing appliances and things like that. And they've done a lot of surveys on this technology. And they found that roughly about 70% of businesses are getting into this stuff. But the other thing they've discovered is that about only 13% of those organizations actually believe that they're doing it right. So in other words, a lot of people think this is a good idea, but most of them haven't quite figured out how to implement it within their environment yet, right? The trough of disillusionment approaches. Yeah. So sounds a little bit like service-oriented architecture. You know, you've probably been to my talks. I mean, I don't know, going back to some of you will remember John Apps and me would do talks on service-oriented architecture like decades ago and so forth. So this sounds a bit like what you were talking about 10 years ago, Brett. Yes and no. Okay, so similar concepts in terms of creating modular and flexible systems, but there are some differences in the communication style. SOA tends to be inherently request response. You make a request, you twiddle your thumbs waiting for the thing to respond. Event-driven architecture, no. You've flung the event onto the event bus and you're getting on with the next thing. Okay, and you can be safe in the confidence that anything that wants that event will have subscribed to receive it and it will do its work with it, potentially produce more events and so on and so forth. Okay. Sounds a little bit like message queuing. Again, yes and no. Well, to be honest, it's a lot like message queuing, and I'm just trying to fake it here with these diagrams. But more often than not, message queuing in a traditional sense is almost one-to-one. You've got a producer of messages, shoves them on a queue, and there's a consumer, okay? Whereas enterprise-driven architecture is more pub-sub, publish-subscribe, right? You don't think of it so much as a queue as opposed to a topic. So you've got these consumers that are interested in certain events, certain topics. So they're subscribed to receive them. It's not one-to-one, it's potentially one-to-many. Could be one-to-one, it could actually be 1-to-0, could be one-to-many. Could indeed be many to one. Perfectly legitimate use case, Anders. Yes. This is an old friend of mine, Alvaro, who wrote the first book on RabbitMQ, which is a popular product in this space. And Alvaro now works for Microsoft, and he kindly sent me this data from Azure Cloud. And in Azure, they have Service Bus, which is essentially message queuing, I suppose, and they have Event Hub, which really is more about event-driven architecture. And Alvaro gathered together some of the data of what people are doing within Azure Cloud. And as you can see, there's a disturbing amount of information flying through these systems, right? There are people seriously making use of these sorts of technologies to implement essentially event-driven applications. And for those of you who are really old, possibly slightly older than me, you'll get Alvaro's joke about 10 years after. And if you do, you can tell me later. Why do you need it? Because I said so. Key benefits. It allows you to build in a lot of flexibility in terms of your applications. It makes it easier to change things. You can change one bit without breaking other bits. It makes it easier to add new bits, new functionality. You tend to find that these environments are credibly fault tolerant and resilient just by virtue of the infrastructure that you're building the applications around. And okay, yes, it is trendy, but it's also a great technology for, as I say, integrating your legacy systems, and we'll come on to that, but integrating your legacy systems with the new fancy thing that the boss just decided that they needed to buy, right? Because a lot of this also is very, very standards based in terms of the protocols that are used and so forth. More key benefits, I'm doing the hard sell here, right? Scalability, loose coupling. Loose coupling's a really big one. Like I said earlier, getting back to that diagram, you plug in a new system. You haven't broken anything else. It's just a new subscriber to some event or another. No problem. Okay. And if you set this up right, you can do essentially near real-time processing. Okay, there's minimal delay on the event bus. If something's there poised and ready to consume a message, great. Okay, but if the reporting module goes down, okay, you'll just get a backup of messages sitting there in the queue until reporting comes back online, but it hasn't broken anything else in the system. Oh my golly gosh, there's more benefits. But the point here, and I'm going to start getting on, I think, to the areas like change data capture and so forth. But fundamentally, the first point there, I think, is somewhat important. The value of knowing about an event and being able to react to it degrades over time. The value of the data degrades over time. Getting back to my opening remarks around batch processing and things like that versus being able to deal with the things as they happen. Time is money here, right? In fact, I think there's a pop-up if I push that button next that says something about time is money. And event-driven architecture allows you to kind of deal with that kind of scenario, okay? There are downsides. You do end up, down the bottom of the slide there, you do end up, it's a simple enough concept, of course it is, but you do end up with a lot of moving parts, right? So, there will be added complexities around things like logging. If it does break, where the hell did it break? Or even knowing that it's broken. I mean, the reporting module doesn't know. There could have been no orders for the past 2 days. It doesn't know. It just didn't get any messages to consume. So, things like monitoring and things and so forth, it can be a lot more complicated. More moving parts, things to worry about. But hey, that's more fun. So this is the scenario I said that kind of precipitated this whole journey, was really the batch versus event-driven scenario. And I forget, what's her name, Veruca, something or other out of Willy Wonka and the Chocolate Factory, And it's this mentality, I don't care how, I want the information now, right? I don't want it in 12 hours time when you do that batch run. I want it now. And batch processing, okay, yeah, there are pros and cons. It can work well for large data sets. It can be very cost effective. But as I say, you get delayed outcomes. And in today's world, we talk about agility. I really don't like that word. But the quicker you can move, the better you can do business. The customer that I was talking to that precipitated all of this, it would have actually helped a lot. Instead of doing those batch jobs, it would have allowed them to optimize their distribution network in better ways. Okay. So the key difference, batch processing, maybe you do a batch run overnight or whatever, event-driven, things happen when they happen, right? You process the data as it arrives, reacting to events essentially in real time. Like I said, the main issues there are some added complexity. Okay, and we'll talk more about this later. So the key entities, well, that's kind of self-explanatory. You've got things that produce events, you've got things that consume events, and you've got something in the middle that routes them where they need to go. That was nice and simple. So what options do we have for that, thinking in a VMS world to a degree? Okay, so some of the more commonly used technologies in this space are Kafka, which is essentially event streaming. Products like RabbitMQ, which is message queuing, but now also supports streams. I've put up there also Red Panda because it's a C++ version of Kafka, and in my opinion, it's better. Kafka is too much messing around to get going. Red Panda actually works very, very nicely. A lot easier, in my opinion. And for all of these things I've listed here, we have clients available on OpenVMS. So if you think of these products as providing the event hub, there is absolutely no issue with your OpenVMS environments, your legacy OpenVMS environments, integrating with and leveraging the capabilities of these products, okay? Some more examples. Because we're in Sweden, I mentioned Larven MQ, and the Swedish people in the room will know what Larven means. I believe it's avalanche. So Larven MQ is essentially a copy of RabbitMQ, written in a different programming language, written in a language called Crystal, which is kind of like Ruby on steroids. It's Ruby that you can compile to native code, uses the LLVM compiler backend, very nice. The two little logos beside Larven are Microsoft's Azure Service Bus and the Event Hub, my friends at Solace. Again, you know, VMS can interact with all of these things. We have an API for OpenVMS that can exchange data with Service Bus and Event Hub in an Azure cloud. Not a problem, okay? I did make a comment there only on integrity in x86. Oops, that goes against what Darius said earlier about us being mostly compatible on Alpha. That's an area where we're not compatible. And that's because the C++ compiler, as people know on Alpha, is not as good as integrity, not as good as x86. But my point here on this slide and the previous one is that from a technical perspective at least, there is no particular impediment to OpenVMS participating in these kinds of event-driven architecture environments. Okay, this is a pretty quick slide and kind of boring. I mean, what's an event? Well, an event is what you want an event to be. I mean, in business terms, you know, it could be a customer request, it could be an invoice received, it could be a sale made, inventory updates, and so forth. But, you know, people like to come up with all this other stuff, error events, you know, user events, whatever. All sorts of things can be events within your computing environment, within your application environment. Common use cases for event-driven architecture. Streaming and auditing, you know, what's going on in my environment. And possibly in one of the examples, if I feel incredibly brave and do a little bit of a demo here, you know, streaming data from, think about data sources on OpenVMS, you know, the audit server, accounting logs, all sorts of interesting data sources, you know, streaming those events in real time so that someone somewhere else in your security team or whatever can actually monitor what is going on within your environment. Internet of Things is kind of an obvious one. You know, you're connecting your sensors up to the event hub, and anything that's interested in consuming that data can do so. Payment processing, that's another good one, and integration in general is an event-driven architecture use case. And like I said, you know, think about some of the data sources that are on OpenVMS. And I'll get conversations with customers. In fact, that second customer I mentioned where I said, is there anything else we can help you with today? One of the things they wanted to do was ACMS audit logs, for example. So they've got a very large ACMS application. Users do stuff. ACMS tasks get run. They want to be able to, I don't know how you would describe it. They want to be able to monitor things going on within that environment, essentially in real time. They want to have traceability all through their OpenVMS environment, through all the different software components. So if something breaks, they can figure out where the problem might be, or if there's a performance issue, where is the bottleneck, and so forth. So, like I say, you know, no such thing as a free lunch here. You know, what Brett's saying sounds really cool. and we probably should go out and buy event-driven architecture tomorrow. But there are challenges. Like I said, the main thing is you're adding more moving parts, okay? And a key element, like I said there, with event notification is that the source of the event usually doesn't care about a response. It's saying, I've done my work. Here's something that something else on the, something else in the enterprise might be interested in, and it chucks out an event, right? Here's something that happened and you might be interested in it. Great. Okay. Well, that is great. That can yield a lot of benefits, but it can also cause a few problems, like I say. And it's important to consider these, right? Increased complexity, ordering and consistency can sometimes be a problem. And when you're dealing with message queues and you've got multiple consumers and things like that, ordering can be an issue in a kind of a publish subscribe environment. If you've worked a lot with message queuing, you know about these things. I'm not going to go into the boring details of ACID transactions versus base transactions, but guaranteeing consistency can also be a challenge, and obviously synchronization. If you're really interested in differences between ACID and base, I mean, most people know what ACID is. I mean, that's your standard kind of, two-phase commit relational database thing. Atomicity, consistency, isolation, and durability. Whereas base is basically available soft state eventual consistency. I'd like to meet the guy who actually spent some time with a pen and paper figuring out how he could come up with base, right? Well done him. But essentially the idea with base is that it's a completely different consistency model. It's not wrong, it's just different from maybe what we were all brought up with, okay? Not really going to spend too much time here, but like I say, in terms of the challenges, yeah, service discovery, I'd say, is not really too much of a challenge. Your service bus is out there and maybe your service bus is clustered for high availability and so forth, but fundamentally, there's generally not too much of an issue discovering the services, unless you've configured the darn thing wrong. So you haven't defined the topics or the queues or whatever. So messages don't actually get routed where they're meant to go. That would be pretty bad. Error handling and fault tolerance. Most of these products like Kafka, RabbitMQ, etc., are clusterable. They can be made highly fault tolerant. Not really a problem, but again, it comes down to knowing what you're doing to configure up that environment to make it fault tolerant. Error handling, monitoring, knowing what's going on within the event-driven architecture environment. Okay, and security, of course, is always a concern because these things generally you're talking about a distributed application environment, possibly involving a cloud like Azure and multiple different parties, right? You don't want to get hacked and have somebody siphoning off events and doing nasty things with them. So a lot more complexity. Life used to be so simple when I was a child. Relevance to legacy systems. Well, like I say, this whole thing started off with these customer discussions. And it occurred to me, well, surely we can actually leverage EDA, event-driven architecture, within a legacy context. What are the ways we can do that? And kind of the first one that came to mind was really this whole change data capture thing. A process writes a record to an RMS file, they write a record to a database, whatever. We don't want to turn the entire application on its head, but if we could intercept those changes, those updates, those writes, those deletes, whatever, and they're events, right? And then we publish those events, and other systems that are interested in them can process them in near real time instead of waiting for that overnight batch job. Now, obviously, not all legacy systems work this way, but there's actually quite a number that do. Okay, so like I said there, modernization without replacement. This isn't rip and replace. If you look at, and I'll talk about it a little bit later, we can introduce some of this stuff without you having to turn the legacy application on its head and rewrite major chunks of it or anything like that. I won't go through too much of that because it's lots of words and I'll run out of time to show you the more interesting stuff. But the bottom line is there's often a lot of scope, and I've talked about this before as well, just really around integration in general. The number of times I talk with customers and they think their VMS system is like, Gilligan's Island or something. A desert island where people are trapped on it. Sorry if for those who never saw Gilligan's Island, but I'm showing my age. But, they think the VMS system, I can't get anything into it. I can't get anything out of it. It's some kind of black box and so forth. It's not. You can use modern integration techniques to hook into your legacy applications bidirectionally. you can push information out, you can get information in. And these are standards-based interfaces, right? So it's just win-win all round, really. So just some slightly boring stuff here, but what are the strategies you might use to hook an event-driven architecture into your environment? I've mentioned change data capture, polling mechanisms. I absolutely hate polling. That's just evil. So, and should try to be avoided. Some applications you may need to write some kind of wrapper interface or whatever to actually give you the facilities to hook into your event bus and so forth. I've mentioned one of our products there, WSIT, Web Services Integration Toolkit, which is not a great name for the product, but it was the name it was given at birth. Maybe we could change that. But WSIT has some very good capabilities around generating interfaces to legacy applications, right? So you then end up with this essentially an API-based integration into your legacy application code. Again, won't work well with all applications, but it actually works quite well with many. It'll work also with ACMS. So this tool can be used as a mechanism of providing an API-based interface to your legacy application that you can then, via various products I mentioned previously, hook into an event bus and make part of an event-driven architecture environment. But the main one I want to talk about here today really is the change data capture thing. You know, as I say, something's written to a file that's going to be processed at midnight or whatever. Let's intercept that write as it happens and actually process that data in real time, okay? So looking at a very simple diagram here, we've got some data store, there's events occurring on that data store. It's an RMS file, for example, or an RDB database table, doesn't matter, whatever it is. There are applications that are inserting records, deleting records, updating records, et cetera, et cetera, et cetera. Every time that happens, the change is pushed out to that consumer box and the changes are published to the event broker, and 0 or more processes consume those changes and do something with them. So I'm not going to go through this, but just some of the things that, something like change data capture offers. It allows you to actually do some of this cool new stuff without having to rewrite your entire application, okay? And it's generally relatively unobtrusive. Hein will talk about that later today in the context of the RMS change data capture solution that we're working on, that the overhead is relatively minimal, not to the point of being zero. I mean, you get nothing for free, but quite small, unobtrusive, generally speaking, unless you've got a system that lives on the edge. But, CDC, maybe you want to use it for real-time analytics, and the demo or the example I've got is kind of an illustration of that. Tom and the guys with JCC Consulting, database replication. Okay, I've got an RDB database, I'm doing transactions on that database, let's push them somewhere else, right? So looking at, as some of you will know, that Attunity, which was acquired by Click some years ago, essentially pulled the plug on support for their change data capture solution for OpenVMS. And there are a not insignificant number of customers that actually utilize that Attunity solution, and they've asked us if we could help. And via various bits of work that I've been doing over the years, we're kind of starting to evolve the solution in that space. And just one thing I'll stress there is that I'll use the word solution, and Hein can back me up on this, is that it is a solution. This isn't, this stuff is not a product. It's not, here's something you install, next, and then run. Every customer situation is different, and it needs to be a solution where a solution is a product plus some services, okay? But so we're working on a solution here, and we're looking at leveraging a component from Brian Schenkenberger, who some of you might know. Brian wrote the original RMS interceptor for Attunity that's used by the Attunity solution, and we're working with Brian to incorporate that into our solution as well. So the idea is essentially RMS-based application, RMS things happen, inserts, deletes, updates, whatever. The interceptor intercepts those system calls. That data gets processed by our CDC solution, and there are assorted targets that information can then go to. Okay, and the solution you get a raw RMS record. We can optionally do various things with it. We can transform it into various formats, JSON, SQL, CSV data, whatever. You can configure it so it can do various translations of some of these records. Like if there's a UIC, it can translate it into the person's username or something like that. All those fascinating different numeric data types that COBOL has, it can handle the whole lot. In terms of protocol support, we're predominantly using AMQP at the moment, Advanced Message Queuing Protocol, but there's basically support within the solution for other protocols via dynamically loadable shareable images. So, as I say there, this solution is evolving. Essentially, it doesn't add a lot of overhead within the OpenVMS environment. A little bit more about that later on. And we're working with a number of customers to develop this solution. And like I say, this is some of this stuff is very specific on a per customer basis, with essentially a fairly common nucleus. Hein will go into a lot more technical detail than I'm going to. I also I also managed to get this thing that we've been working with RDB. Don't panic. Don't panic. But it was more for just my own edification, to be perfectly honest. But another point here that I always like to think of animal names when I'm creating these programs, and the name of this one is Vole, which is a small rodent. And I was trying to look for a picture of a vole, but I couldn't find a good one, so maybe next time. So some examples and a bit of a tangent here. So at the last boot camp, I rather foolishly did an ACMS on x86 demo. And I thought, well, that's a really boring thing to actually do a demo on. So I hyped it up and did all this kind of amazing stuff. And I thought, this is going to break at some point and end really badly. And surely enough, it did. I think Tatiana and a few others here today were in the room, and things were going well, and all of a sudden it just fell apart on me. But such is life when you're doing live demos. So this is a much more reduced demo, and it doesn't matter so much if it doesn't work, because I've got a backup solution which is called PowerPoint. But essentially the idea is it's a coffee shop simulation, right? So some guys open some coffee shops in New York, and you go in there and you buy your coffee and so on and so forth. And so this was written a long time ago, so it uses ACMS and it uses RMS files instead of a database and things like that. And then it kind of evolves because the guy that owns the company decides he wants a web interface, and there needs to be a web app and all that sort of thing. Well, we've got a web app, but we haven't got a phone app. And then he wants sales data replicated off platform. Well, we can do that with change data capture. So, because he wants to see how his business is going. So we'll see how all this goes. Anyway, but just what I'll try and show you here is we've got a little client, and the client is really boring. It's just running on Linux on my laptop, that is just doing ACMS transactions and, to randomly buy products from one of the 3 stores. Okay. So we're happily selling stuff. Everybody's happy, but the boss wants to be able to see this stuff in real time. How much money is he making? So let me just see if we go onto here. So let me jump out here. So this is what we'll see if we can demonstrate, and it probably won't look quite this fancy, but essentially for this bit, which is nothing really to do with change data capture, but this is kind of a little bit for Tuan when I was talking to you a few weeks back about Prometheus and Grafana, which are really nice and quite common tools these days for monitoring applications. So we have an API that works on VMS, and you can hook that into applications. So if I drop down to here, and if by some miracle things work, what we'll do is we'll set this gurgling away. So it's going to start making sales, okay? And it's set up so it chooses a time, they're not selling a cup of coffee every microsecond, okay? So it selects a few seconds here and a few seconds there, and it makes sales. And, so this is people buying stuff in the store, okay? If we then go to the browser and, if some miracle happens, Well, that's another thing with Prometheus, which is just monitoring one of my VMS systems back in the lab, but that's another story, not the one we want. We want the other dashboard, which is the coffee shop sales. So here you can see I just started this thing. Okay, so there are sales occurring. So the graph on the left is sales per minute in each of the stores, and the graph on the right is cumulative sales. So this is how much money that the owner of the company is making. And I probably need to adjust the refresh rate on this, but I'll just refresh it manually because I'm feeling lazy. But as you can see, as transactions are occurring, we're monitoring that application essentially in real time. So the boss can sit there and rub his hands together with glee, and maybe he thinks that the yellow store, whichever one that one is Hell's Kitchen store, maybe the staff need to be fired because they're clearly not selling enough stuff, right? So then he thinks, well, okay, how can I sell more products? So let's create an online app. So what we need to do now is jump back here. And Igor down the back of the room very kindly created this little app. So if anyone feels inclined, scan the QR code and you'll be taken to a little website. And this is, I'd also point out that the app that Igor's created for me here is running on DigitalOcean, and it's a VMS VM running x86, okay? And it's talking via WSIT and various other bits and pieces to going through the cloud using RabbitMQ and Cloud AMQP. I should have put a diagram on here, but there's a lot of connections going on. But essentially this store is, the online store, online interface to that ACMS application. Now, if I drop out of here again, and I hope that someone, it's not very often you're allowed to use your phones in a demo, right? But if in a talk, but if somebody's scanned it and is in there, can you please make a big purchase? Buy like 10 or 100 of something or other. And if I do a refresh, you should see that, yeah, right, someone's gone and bought a lot from Hell's Kitchen, right, because he doesn't want his mate to get fired. So as I say, I can't be bothered setting the refresh. So yeah, you get the idea, right? So we're actually monitoring this application in real time. Nice, okay. Enough of that nonsense. Feel free to keep buying product. So anyway, the other thing the boss of the coffee store wanted to do was he wanted us to put RMS, change data capture, on our RMS database, so that all of those transactions are getting pushed through to a SQL Server data store, because he likes SQL data store. He can use, business intelligence tools to query that data rather than messing around with RMS files. So this is possibly not too interesting, but essentially each of those transactions, when you guys buy something in the shop, it's getting pushed through to the SQL Server database, right? So the boss can then go and run queries, and he can see records arriving in here essentially in real time and so forth. So that's all goodness. Now, this is where I start having bad ideas. I start thinking, well, this all hangs together very nicely. What other madness can I do with this solution? And I'm thinking about those conversations with the customers, right? I'm thinking, ACMS logs, Apache log files, system error log, accounting data. Why don't I go really crazy and do T4 data, right? T4 is a batch process. You don't get to create the graphs until the next day using TLViz or whatever it's called. I thought, is that what it's called, Jeremy? I can't remember, yeah. But anyway, I thought, I've got the technology. Let's put something in place to intercept all of this data and publish it, and then let's go really stupid. We can have one consumer here, which is our VSI change data capture ingester, and it's going to write data into SQL Server. There could be something else out here that you as a customer, you want to get all this data into Splunk or whatever. And I thought, I'm just going to be really crazy and go for, I don't know if you've ever heard of Logstash and Elasticsearch and Kibana, but they're kind of a coherent suite of tools that work really well in this environment. And basically Logstash can consume things from just about anywhere and push that into Elasticsearch, which is like a large NoSQL database that you can then do interesting queries on to report on all sorts of data, typically used for, say, mining log files, real-time data sources, things like that. Like I mentioned, a lot of our customers will say something crazy to me, like they'll say, Brett, can you throw the VMS accounting data, can you throw that into Splunk? No, I could, but it would be useless to you because the accounting file is a rather complex RMS record format. Actually, it's multiple freaking record formats. You know, there are data structures forever that define the records that, well, I'm exaggerating, but there are a lot of data structures that define the information that's in the accounting log. Similarly, T4 with monitor, which is output from monitor and so forth to a file, the ACMS log. They're all binary RMS files with certain attributes. You can't just go and chuck them into Splunk and expect Splunk to do something vaguely useful. Yes, you could with the Apache log files and so forth, not a problem. They're just text, but not so much the others. So it occurred to me, you know, there is no Splunk or Dynatrace agent for OpenVMS. We've got products like VMS SPI that can publish events to Splunk and Dynatrace. That's cool, but we can't really do a lot of other stuff. Why don't we just come up with a solution that takes this information and puts it into an event broker, and then the customers, developers can do what they like with that information and stick it where they like. They don't have to have the conversations with me about how do I get access to the accounting data, because it's in a queue in the event broker. They can just go and read all the records from there when they feel like it and do whatever they like with them. Okay, we will transform them into JSON or something else. Fine, it's human readable. Okay. I hurt my back doing this because it was like Easter time or something, and my wife didn't have any plans, which is strange for her. And so I sat on the couch over most of the tapping away, writing the code for all of this stuff. And of course, I then ended up with a very stiff back. But anyway, I'm going to jump down to the browser again in a minute. But essentially what we're looking at here is what I've set up with some of these various data sources. Okay, so these are queues within RabbitMQ. We've got ACMS audit and error log. We've got Apache access and error log. We've got the copy shop, which we looked at before. We've got VMS accounting, VMS auditoring. We've got error log. We've got intrusions. We've got opcom messages. We've got T4 monitor. We've got T4 XFC. Right? I can add more and more of this stuff. It's not a problem. Give me a data source. We'll whack it in there. Any process you like that's interested in this stuff can then consume the data out of those queues. Right? So if I jump out of here and if I go back to the browser, this is where I'll start losing track of what the hell I'm doing, so my apologies. But if we go back here, for example, here's a live rabbit, which is actually on our network, going through the VPN there. Now, as I say, we've got all these various data sources. If you look hard enough, you'll see that every so often there will be a few accounting records written, maybe half a dozen or so. This is just normal activity on the VMS system. But if I do something like run a few, if I use just the AB tool, for example, and go and run 1,000 HTTP requests through here, right? So I'm running 1,000 HTTP requests. If we then go back over here and have a look, you will see that the number of messages in this guy are going to jump up fairly quickly. There you go. So that's actually happened. And most of that is actually the refresh cycle of like 5 seconds that I've got on the screen. It's nothing to do with how quick the message queue receives the data. Likewise, if I mess around with my shop, which hopefully is still running, we might see some things happening with the shop. Okay. You won't worry about the little error message that was there. This is only a demo. If you have a look at the shop, we should see some more messages coming into shop transactions, 266. That should jump in theory. Well, the accounting log just jumped. So You should also see the ACMS audit log jump. So what's that, 1,076 at the moment? If I run a few more transactions through there. We got there 1,000. Oh, we're still gurgling away. Okay. Okay, so it's gone up from 1,076 to 1,088 now. Okay, so these are transactions going through ACMS as they happen. We also see our coffee shop transactions. They're a little bit different, but you can see that stuff is happening. Okay. And what does this stuff look like? It's a good question. Let's have a look at this queue. If we say just go down here and grab a message. Well, that's a pile of gibberish, obviously, which isn't terribly useful because it can't display it. It does contain some binary characters. So, you know, this is where Brett's an idiot and picks the wrong queue. But let's pick one that's easier to look at. Say, well, the Apache access log, that's boring because it's just an Apache access log record. Okay, right, so who cares? Okay, but the point is that the customer that wants this information put into Splunk can consume it out of here. They don't have to copy the Apache logs off of the VMS system. They can just take it out of here. And in terms of performance and so forth, even on this very, very small environment that I've got here, we can quite easily exceed 20,000 messages a second. So if I really start hitting the Apache web server really, really hard, you will actually see on this display here, for example, you will actually see that, you know, the incoming message rate will be something like 20,000 a second. So it can really belt through them. Okay, so just some examples here of data that comes out of the ACMS accounting logs and so forth. And so this is going through our change data capture solution being stored in SQL Server. You can then run queries against it, et cetera, et cetera. Okay. T4 as it happens, right? And this was funny. I was having a conversation with Tilo Lau, and sure many of you know Tilo. And Tilo's going, Brett, well, this all sounds very clever, but have you thought about Heisenberg? I think about Heisenberg very often. And of course, what he's referring to, and Wolfgang's far better qualified than I am to talk about the Heisenberg uncertainty principle. But essentially what Tilo was saying, Brett, is have you considered, you know, how much is this thing impacting the performance of the open VMS system? Is the act of making the measurement actually affecting the result? I was fully aware of this possible notion. So this is actually very, very lightweight and quite unobtrusive. So again, we can monitor work in progress. We can monitor this in near real time, T4 data coming through. And what I've done here is we get the T4 data, there's some conversion. Can't remember what I converted into now, but into something that's useful. It's published to Rabbit. Logstash from 2 or 3 slides ago consumes it out of Rabbit and publishes into Elasticsearch. And I can then use Kibana, which is a client for Elasticsearch, to produce these pretty little graphs. So I don't know, there's probably
still the sampling interval for us.
Basically, well, yeah, like if you set the sampling interval to 10 seconds and you set the flush interval so it's actually writing stuff to disk, yeah, that's what it's coming through at.
Okay.
Yeah. So just very, very quickly, because I'm conscious I'm talking too much, but you know, so there's not much. I mean, these graphs are very crummy because I tell you what, you need a license to drive Kibana. It's not easy, you know, and I'm like an old guy. This needs to be, I need Igor to create these graphs for me and they'll look beautiful. But this is essentially in real time for the last 24 hours. I could jump back to, you know, I mean, I've been traveling, so not much has been happening over the past 7 days, but you know, whatever. It all works, it all hangs together. And like I say, I've only put 2 or 3 metrics on there, I think CPU time and buffered and direct IO or something. So don't worry, Tatiana, I've just got a couple more to go. So yeah, in summary, you can actually have some fun with event-driven architecture and do things with it that you might not have actually thought about. And I guess that's kind of the point I'm trying to make here. But there is no free lunch. there's a lot of complexity here. You're introducing more moving parts. That means there are more things that can break. So you have to be careful about how you set this stuff up, making sure it's robust, reliable, secure, that you have mechanisms in place to monitor what's going on, so on and so forth. But you can have a lot of fun. And this is tight coupling. Highly undesirable on multiple levels. But the point I've made in the box up there is that software engineering today it's almost not so much about sitting down and developing something from scratch. You can get all these bits of great work that other people have done. And John, you and Denis are talking about this tomorrow or whenever, where you're leveraging deoxygen. You didn't write a line of that thing, but you've managed to create a great solution with it. So it's about having a look at what's lurking around out there and coming up with interesting ways to stick all those bits and pieces together and do fun stuff with it. Yep. So I think that's me done. That's a wrap. Any questions? I ported, do you know what Rabbit is written in? It's written in the Erlang programming. Okay. I ported Erlang to OpenVMS over a decade ago. It hurt. Could we do it again? Yeah, possibly. But is it worth doing? I mean, maybe if I'm bored next Easter or something, right? Yeah.
Is the position doesn't really care about who's what's happening in the message. Is there like a direct solution if the consumer doesn't consume fast enough the data that is coming? So like the queue for
Yeah, so I mean, this is really, like I said, it's around configuration and monitoring. Okay, so within any message queuing environment, you can set up TTLs on the message, for example. So if the message, if the TTL fires, that message is going to go into a dead letter queue or something like that, or maybe, an alarm is triggered if the queue length gets greater than X. But that's all configuration stuff, really. Yeah.
So just have to make sure that you can.
Yeah, so don't just, like what I've done here is totally vanilla. Wham, here's some queues, put some data into them. If I was doing this for real, I'd be thinking about those sorts of things. Exactly, yes. Anyone else?
So you have Kafka for events thing, and you have your RabbitMQ more for messaging. But now my question is, when should I use what?
You've got to look at the use case. I mean, obviously, there's a difference between a message queue and a stream. Yeah. Okay. But the one thing I would say is that Rabbit actually supports both. And if you noticed, I don't know if it's if I jump out of here, Tuan, but if you have a look, and this is, you can also do some fun stuff here. Sorry, I know I'm standing between you and lunch, but if you look here, in addition to creating the queues, I've actually also created streams in Rabbit. Now, these aren't Kafka streams, but Rabbit supports both streams and queues. So, and you'll notice that there's a striking similarity between the numbers in the streams and in the queues, which I haven't consumed from, because you can configure this up so that the routing is such that the message goes to both, right? So one of the things I quite like about Rabbit is the fact that it gives you that flexibility. You can have the queue, but you can also have the stream. You can have both if you want to. So this is a permanent record of all the HTTP requests. The messages in the queue are a little bit more volatile, right? You consume them, they disappear off the queue. This is a stream that just grows forever, or until you archive it or do something with it. Kafka just gives you the stream. Yeah. Anyone else? Lunch.